Hello friends, greetings. Welcome to How to VLAN channel. This is DB VLAN stream. Today in this video, we are going to see Oracle automatic block media recovery. When does it happen? How does it happen? We are going to do a deep dive into it. I'm sorry folks, I was not able to upload video for last 2 weeks. I've been quite busy with my work, so I couldn't do it. Sorry about that. Let's get into the video now. As usual, we start explaining the procedure we are going to follow to test this automatic block media recovery. That's our lab objective. And then I'll show you through the screens how our lab is set up and so on. Okay. First, our objective is to demonstrate the automatic block media recovery in Oracle, a particular event or an error which is ORA-1578, which is printed when this happens. Version we are going to test is 12.201, but this feature is now available from 11G release 2 when Oracle introduced real-time query database or active data guard feature. The primary database in our case is this and standby is this. It's not a container database. Prerequisite, the standby database needs to be in active data guard mode or in a real-time query physical standby database. Caution, for block media recovery to work automatically, the physical standby database must be in real-time query mode. An Oracle active data guard license is required. So this is a safe harbor notice such that you will need an Oracle active data guard license if at all this feature needs to work for you. So exercise caution guys. First step, verify the data guard configuration. So this is commands we will run through, and then we will be setting up a test user and test data, load some test data, and then we will check if the data is accessible fine without any errors. We normally won't do this tracing and stuff for a normal select query, but for this particular test we need it to, because we are going to see particular event getting kicked off in Oracle when this really happens. So in order to trace it, I am enabling this 146 trace. And then we will manually corrupt the block. This normally doesn't happen. We as a DBA, we never corrupt the block ourselves. But this block corruption can happen because of the media issues, storage for instance, or any underlying stack, for instance OS or virtualization layer or storage. It can happen anywhere in the disk. So in the IO path, whatever technology that is involved in the IO path, where this can happen anywhere. So we verify if the block is corrupt. Yes, it should have been ideally because we corrupted the block, right? So, and then we flush the buffer cache and we try selecting the data again. What would happen is this time you will face an error after you corrupted the block. We will see in the alert log also there will be a message printed, but nothing happens. No automatic block media recovery. So you have to manually recover the block. We will recover the block using a recover corruption list. This is also an Oracle feature which allows you to recover all the corrupted blocks in one go. You can have one or you can have 100 or 200. I ended up recovering at least 130 blocks in one single go with this command. So just be aware so that powerful this tool is. This command is. And then you have again to validate if there is any corruption found. And what all it relies on? It relies on the standby copy, it relies on the flashback log, there are many places, and then I think it relies on the backups and so on. So it will be able to fetch, this particular command will be able to fetch the good block from many places, so and it will recover it and then retry the data again after the recovery is done. You will see no errors now. All right. And round 2, this is the real requirement wherein the database will be in the standby database will be in real-time query mode or active data guard. So again I put the safe harbor notice here. We put the database in read-only mode. Now this time you open the data guard. Earlier it was in mount state. Now we are opening it. When we open a standby database, it will always open in read-only mode, physical standby. So we verify the standby status and so on. And we flush the buffer cache. We corrupt the block again, the same block. We again try to fetch this data again. This time there will not be any errors for the end user. It will just simply get the data returned to you because the automatic block media recovery already would have kicked off. End user should not face any error this time. Alert log will reflect that there was a corruption recovery happened automatically. And this is what our objective is, and this is what we are going to see. And now, part of our lab, the screens. Now you need to know which screens are what. So this is our first screen. This is where our sys user will be connected to the primary database. This color is for primary, and this color is for standby. Whenever you see this color, this is for standby. Wherever you see this black and white, then this is for primary. All right. So let's get started. All right. So our environment settings. So on top of it, I have two windows open, one for the standby alert log, one for the primary alert log. Okay, this is where the end user actions will happen, which is just selecting the data and so on. Okay, let's get started. As usual, our environment settings. This is primary database, GGSR040 we saw, and this is standby database, GGSR040 SB1. Let's get started now. I'm going to connect to the DB. It's already up and running. We just need to select the database information to see how this is working, how this is set up. Is in read-write mode. Start up today morning. These parameters are needed for the database standby configuration. So we have GGSR040, GGSR040, SB1 participating in this standby configuration. This video is going to be pretty lengthy, so keep watching until the end, guys, to understand this feature. So you see here, location USDB recovery file test and use service GGSR040 SB1 has been valid for. Okay, so this is our standby destination, GGSR040 SB1. All right. Now let's check. So this is for the standby. So I don't need to do anything. All the others are for standby. Now let's go to the standby and see how this is set up and active. We verified the primary until now. Now it's our turn for the standby. Right. So is in mounted state. So this is not in real-time query mode. So see, this was started just before few minutes and is in mounted state. Again, GGSS 040, GGSS 040, SB1. Okay. And log archive test. Again, primary is for here and standby log archive test 2 is GGSS 040. Whenever this standby becomes primary, then this log archive test 2 becomes effective. Otherwise, it has no meaning. And let's see if the recovery is running. No MRP is running. So let's see if there are any restore points. None. Let's kick off the recovery and we'll check the rest. All right. So I forgot to put disconnect. All right. Let's see. MRP is started and it came out as well from the prompt. Otherwise, it will never come out if you just don't put disconnect. Okay. So let me just check the MRP process if it is working. So MRP is applying log 54. And yes, we'll check the log. It will not show anything here, but standby log will show which sequence it's applying. 54, right? It's in memory. Similar query, you can run it in the primary. So I'll talk about standby configuration in another video. This video is only for testing this ABMR, automatic block media recovery. So we're not going to discuss much about the standby log usage in the standby database. Okay. So 54 is the current and 54 is already in the memory of the standby redo log. So let's go. So this is pretty fast. So there is no lag. So now let's set up the table. Let's go forward and create the user. Let's capture the screens. All right. So as we normally do, we should never leave this without capturing. Output primary. Output standby. Now let's create the table space and the table user. We do this in the primary database, right? It's created, and we create a table space for the index. And today in this lab, we are going to only see the table corruption, not the index corruption. So I'm just telling you this. Yeah, so table space. We just need to keep this table space. Index to show, index to go to index table space. Alright, so let's go. Alright, so the table spaces are created. So the table spaces are created, which is data and index. Now it's our turn to create the index. Sorry, not index, the user. The default table space is ABMR26 May. We grant necessary permission to the user for creating the table. And just do this, create table. Alright, so this is done. Now let's capture these screens. This will be done only in primary, so we move on to the next, creating the table and index. Now we have to go to the end user screen, so where we will do the operation. So already set. User is connected. Let's create the table. Table created, an index. Index is also created. Now let's load some data. So the user is this. Let's load some data. Okay, so I'm using the row source generator. Connect by level. So line triple line rows inserted. So we have completed setting up the test data. Okay, so if I just select this table, I should see 1000 records here. Alright, this is fine now. So let us exit this. So because we're going to establish a new session for the round one. Round one is what? The database standby is not in active standby mode. It is not using active data guard license. It's in mount state. So just flush the buffer cache because we just fetched the data after we loaded it. So we need to get rid of the cache so that we can really query the physical data file. So now we need to see if the data is accessible using the following queries. So all right, so we will just set this. Yeah, so let's have this. We will have a lot of rows fetched in a minute. All right, so this is done, and we just need to set all these parameters one by one. I'm just copy pasting everything. Is done. I just want to see the explain plan. Is explain, and we will see if we get a full table scan. Yes, it's a full table scan. So when you do this, you'll get a full table scan. All right. This is very important because when I'm going to corrupt the table block, I may go through the index to fetch my necessary information. I don't want that to happen. So I want to avoid index scan. That's the reason I'm checking whether I'm getting the full table scan or not. And we will really run this query. All right. Sorry, so just see this error, auto trace. I didn't enable the plus trace rule. How do you enable it? You just need to create this plus trace rule. SQL admin plus trace, then it will automatically create the rule. Then I granted it. So now I should be able to invoke the set auto trace on. All right, so I need to disconnect and connect back in order for this to work. Okay, so now I'll do this again. So we know this already. Anyway, I'll just take it one more time. So it's table access full. Now set auto trace on. Alright, so now you don't get any error for the auto trace. So it's a full table scan and it fetched the row we wanted. This is the output. So let's set auto trace off. We really are not interested in the second part, which is the index scan. So I'm skipping it for now. Okay. I'm not testing this index scan because I'm not anyway going to look at data fetching using index. Because if you run this query just like this, I'll just show you, it will go through an index scan because I have an index on top of it. So you see, it's using the index built on top of it, IDX ABM ORA-1578. So, but our test is not for the index scan, so we'll skip it here. I just capture the screens. Output index scan is index is skipped. Index usage is skipped. All right, now let's move on to the next one. Corrupt the block. So this is very critical, and we need to identify the block number we need to corrupt. Right, let's get started. Right, so for this we have to go to the main screen. So this is the table and it is present in table space ABMR26 as we set it up. And what's the file ID and file name? This is a file we are going to corrupt. Right, and we need to figure out the block number on which this table is sitting, and it is sitting on the block number 131. So our aim would be to corrupt. So you just check block size because we need this number as well. It's 8192. So data file path is the output file. DD is for operating on the files physically. Output file name is this data file. Block size is 8192. You have to seek 131. Block number 131. We are going to convert this into some node rank feature, and number of blocks we are going to corrupt is 1. Input file is dev0, so which means that we are going to corrupt the block number 131. Alright. So if at all you want to see this block, I think I can dump it as well. It's just alright. So I took some. If you can see, I dumped the block just to show you what's the content of it. Data file 8, block number 131. Alright, and this is my trace file where the dump header, dump blocks are found. Block dump is found. You can see it's data file 8, min block 131, max block 131, only one block we dumped. And then block dump from disk. So you see this data. I mean, each one has its own meaning. So Now I'm going to corrupt this data. That's what we wanted to see. You can see the rows also. I think this is a 5-character ID, name 9. I think you'll see the 100 in this 100 dot. It's a number, row ID 100 will be here. Fine. Anyway, this is the block header, block dump. So we preserve this. This is a good one. So before we corrupted it, we took a block dump. Before outer system dump data file 8 block 131. This is a command we need to fire. Yes. And just check the trace file of your session and you should see this output. Alright, anyway, let's not drag this any further. Let's corrupt the block. Okay. So, and then I'll show you one more block dump. This is done. Now the block is corrupted. Now let me capture the outputs of whatever I did until now. Otherwise I will miss this. So we found this and we viewed it and then we corrupted the block. Now we have to again take a dump of the block if you wish. But it's, yeah, we'll follow the steps. So now I need to check again what is the status of my corruption. Did it automatically come up here in the VDollar database block corruption? No, it didn't come up. Does it show in non-log block? Non-log block is for a different reason, so it doesn't. Now I need to run the validate command. I'm going to go in here. So I'm connected to GGS 040. I'm going to validate data file 8. That should result in a failed state. You can see its state is failed. Alright. So now if you run the query on this block corruption, it will report file number 8, block number 131. One block is corrupted, corruption is all 0. Alright. Now if we run a report on this, it doesn't show anything. Alright. So let's capture these results. And I'll dump the data file also to show you how does it look after I corrupted it. Yes, so I'll go in here, just paste it here. Now I'll dump the block header just for the information purpose. So I will, alright, I'll disconnect from here, connect back because I wanted a new session. So a new trace file is generated. So this is the bad block. Now we have a corruption. This is a bad. So this is bad. Just go file trace file, and earlier what we had was good. This is good. I just wanted to store this so you can see how does it show differently, both what difference you see. So now bad, if I go check, still alright, you see nothing came up. Block dump from disk. See hex dump of corrupted block header 4 corrupt. It shows corrupt. So it's not able to do anything. So it shows up in the block dump also that it is corrupt. Nice. Now let's move on. Move on to the next one. Let's close this. So it's corrupted anyway. We got the bad and good. So I'll just break it down. The outputs. Alright. Sorry if it's confusing you guys. It's important. So in case if you guys ask me any question, I can take a look back and then I can respond to you. These traces are important for me. Alright, now let's flush the buffer cache. because we wanted a memory to not be used. I'll flush the buffer cache. Now we just need to reselect the data. I flush the buffer cache, so this way memory will be used. Memory will not be used in the data selection. So we disconnect from this user. We connect again. We set all this tracing. Now we already know, but we will still check if we are doing the full table scan because that is important. UTL xplp.sql. Alright, so let me check again. I missed to set up the formatting. So yes, this is confusing you. If it is, we need to have this format enabled, otherwise we will have these issues. You can see it's full table scan again, and now we need to go back and check the data. So let's do this auto trace on. We corrupted the row which block which corresponds to this ID 100 row. Alright, let's look at the alert log. You see, it's printing an error very much 1578 data fail block corrupted. And you can see here 1208 is just now, and even before also when we ran the validate, after we ran the validate itself, the corruption is initiated. So yeah, 1204 itself, the corruption got started reporting. 1206 corrupted data, and it prints properly the table that was corrupted and user everything, and it's reporting the file ID and block number. And you can see this is properly reporting the corrupt. Requested a dump of selector easily happens the following internal error. Retain all the redo logs generated by the, okay, this is normally reporting. Okay, the redo logs needs to be retained to get you out of this error. So set auto trace off. Now we're not able to select the data, but if at all, I think we will still face this problem, but I'll just show you if, because we need the data anyway. It will only store the row address. See how will index benefit here. I'll just show you. I think this is also reporting as corrupted, but if I select ID from, right, it will work because it's the index. It's a benefit of index. All right. See, even if I do this without, this is how, if I do this way, I'll still face a problem. All right. I'll still get a corruption. Corruption reported, right? But if I run the same query with using index, I'm getting the results. This is why, because index has all the information it needs to retrieve the results for this query, but full table scan doesn't. That's the difference between the usage of index. That's why I'm avoiding index scan here. Okay, hope I think this clarifies you. Now let's secure this output because we got what we need. We got the error, and we got the error reported in the alert log also. So let's move forward now. Just keep our objective clear, and like I said, this is going to be a pretty lengthy blog, guys. Vlog. So stay with me until this end. So it's the error we reported in output alert log. And what does it standby say? 1208. Did it report anything? Nothing. 1208 did not say anything. Alright, so let's move on. Standby didn't say anything. It doesn't even care what happened. in the primary. So fix the corruption manually because ABM or automatic block media recovery did not kick off. Alright, so let's do this. On target. Now we already validated the data file. We know there is a corruption. So we just need to see if the corruption is still around. Yes, it's still there, all 0. Recover corruption list. Right. No backup or copy of data file yet found to restore. Alright, because I didn't actually store, I didn't enable flashbacks, so it is having no choice to bring my data back. So I have no choice. I need to open my standby database in read-only mode to get this data recovered. Unfortunately, I didn't store any backup. So this is the situation we all will be in, right? So I cannot recover block even if I attempt. Alright, I didn't prepare this. I forgot to prepare my lab because I created this table so it's fresh. So I thought about this flashback. If I had enabled the flashback, this would have ideally worked. I didn't. I forgot to enable the flashback as well, so I didn't take the backup. Also, I'm in a limbo state now. See, I'm not able to recover the corruption list. I'm not able to put the database. I'm not able to recover the data file yet using this command. Also, either of this command or this command didn't work. So now, how can I get this one? This is really a challenge, right? This is a challenge. But we know we have a backup. Which backup? The backup in the standby database is good, still good. It's not corrupted yet because the activity or operation of dd command happened outside the database. No way to get this replicated to the standby. So failed. Routine one failed. One. So let's see if we are able to come out of this. Oh God. Okay. If we are able to come out of this corruption now. Alright, recover corruption list. So retry selecting the data. It's not no use because it's anyway going to fail. I can just show you. So yeah. So if I do this selection again, it's gonna fail because it's still not fixed. Still not fixed, right? So it's still not fixed. Even if I flush the buffer cache. It's still going to fail, yeah. So there's no way you can get the data back. Now we have no choice. We have to open the physical standby database into read-only mode. Or you can secure a backup of this data file in the physical standby. Move the backup to over to mm, the primary database, and that way also you can recover. There are two choices you have, right? So I'll try the read-only operation, and then I'll think about the backup and movement of the standby, the data file from primary standby to the primary. Okay. So retry selecting the data. This routine failed because of missing good backup of the data file. All right. We have the database in archive log mode. I still should be able to retrieve it from the redo. Yeah, that's why redo recovery is also not happening. Anyway, let's move forward. I'll wonder about the others later. Alright, so I'm gonna skip this. Now routine 2, we are going into the round 2. I'm hoping that this feature will work. Okay, I'm discovering something new here, so I'll anyway figure out the reason why redo was not used. Okay, so open the standby database in read-only mode. Right, so let me see if it's, we saw it's already in recovery mode, right? So let me cancel this. I wanted to open the DB in read-only. So media recovery is cancelled. It's open. Ideally, I should have put a routine known as a failure scenario itself. So by mistake, I didn't advertise that way. But anyway, guys, we are learning. So I open the DB in read-only mode. Let's see. Is in read-only mode and the instance. Open. This is not mandatory. Here in the standby, in primary it is. But if the corruption is observed in the standby, you will need all the settings to be proper. So, and if I see this, recovery is not running, right? MRP is not found. Let us put the disconnect. Let's put the database in recovery mode. Alright, MRP is introduced. Let's check the MRP process. It's okay. Now, the same query we ran in the primary. Are they working fine here? Let's figure it out. If I do this, user underscore ABMR, this is our table, isn't it? See, it's working fine, absolutely. In standby, the corruption is not there. If I show you this, I don't think it will allow me to write it. Yeah, this is the full table scan only. So, let's see. I don't think it will print the explain plan though. It will not allow because it will not be able to write anything into the plan table. So, being this is in the standby. Anyway, this. Anyway, I just wanted to show you the full table scan works in the standby and it is able to retrieve the record even if I do a select star. Because the select star will ideally not work in with or without the index because it needs the other records. See, it printed fine. This was the information we had before the corruption, isn't it? If I go back and show you, if I show you this, yes, this was the good record, right? MBJXM, MBJXM. So this is okay. So in standby it works fine. So standby the corruption is not there. So we cannot switch to the standby only for this block corruption. We need to fix it as a DBA. We need to fix it in the primary. Okay. Let's capture the output as we do normally. All right, let's capture it. The one here, standby, is not having any corruption. Now let's do the next step, which is to recover the, initiate the recovery, okay? Now let's flush the cache in the primary. We don't need to repeat this block corruption because the block corruption is already there. We are not going to do this. So skip and skip. So we just need to flush the cache once anyway. As part of our test routine, we will flush the cache of the primary database. This is our primary. I flashed it. I flashed the cache. Now I don't need to do this step number 11 because the corruption is already there. See ABMR in action now. Yes, so this corruption is still there. We can check that. Validate data file 8 is still corrupted or not, we'll see. This validate command will not initiate a recovery. See, it still report has failed. It will not initiate a recovery, but a selection from the end user, which is whenever an end user initiates a query on the table, then it will initiate it as per Oracle. And I even saw this in action in last week in the 19C database. I'll see. I fixed it many times. Similar situation. Now we will initiate a query now, right? Alright, now let's do this. The action. This is on the primary now. Again, imagine. Remember, we are in the black screen, black and white. We're in the original screen now. We are connected, and just gonna run the explain plan. Explain. Doing this is primary. Anyway, you use the index or not using index. It doesn't make any sense. You can see it's using full table scan. So let's now put the auto trace and see how does this work now. All right, now it worked. It's wonderful, right? Automatic block media recovery. Now we got the result in the primary itself. We didn't take any action. We didn't run recovery. We didn't run anything. But you see here the message. Let's go back to the time. It's 12:24. We initiated the query, isn't it? Set auto trace on 12:24 45 seconds. So corrupt of the block, rereading the data file for corruption. Same corrupt and no logic. So automatic block media recovery service is active. Request of a blockade was successful. Now let's look at the standby. So this is different. This 12:24. Yeah, same time. Why is it ABMR is getting interrupted? Sorry, why is the recovery process getting interrupted or something new? I see. Shouldn't interrupt here. Let me just check if the recovery is ongoing or not. Was it interrupted for any reason? Oh, sorry. You see, MRP process got interrupted. Oh god, there's something new. Hmm. Why will MRP process? Hmm. I didn't check. I didn't see this happening in 19C. MRP process never gets interrupted during ABMR. It's something new, guys. I'm learning myself. So this is happening. Insufficient privilege. Why? I'm sus. All right. Oh my god, this is something new. Wow. This is something new. I never thought. Oh god, it's dying. It's dying after that MRP process finished. After that real time exactly at the same time it happened. You see, 1224 MRP process died because of ORA-600 error. I'll search with this error code if I find something. Maybe we can check. I'll check it anyway, guys. I will note it down. Lucky that I noticed this in the standby. What is happening? This is the reason why should you have the alert log, the primary and standby running all the time when you end up doing such activity. I didn't notice this is 19C in my real life work experience, but here in 12.2 I don't have any PSC because it's my lab. So I'm getting Aura 600. Maybe it's an issue in 12.2.1. I'll keep you posted if what I find with it. Maybe with the PSC this may be fixed. But Our objective is achieved for this lab, so the data is retrieved. Alright, let's now check if the corruption is still getting reported here. Yes, so it's still reporting because it's not updated yet. We just need to update this. So let's go back to our steps and we will remove this because we're not going to check any of this. So end users will not see. That's what is important, isn't it? End users should not see any error now. That's the important one. So for the user who is querying his bank account statement or bank account updating anything, he will not see any error. It's a wonderful feature of Oracle, guys. I don't know if SQL Server or Postgres or any other database has this feature. So you get what you pay for. So right. So this is cool. Cool. Now, now this feature works as expected. But observations. But observation. ABMR interrupted the MRP in the standby. And this time MRP is not able to start again, failing due to ORA-1578 with this error code. I'll keep you posted, guys, with what I find. Anyway, I think this video is useful. I'm guessing this video is anyway over 30 minutes. I didn't check my calendar, but I used to check every now and then if my recording is still going on, because every now and then I see nowadays I forget if there is I initiate the recording, and then sometimes I may end up missing the recording. So just such things happened in the past. So I was checking. I didn't check the clock duration of this video, but I'm sure definitely it's more than 30 minutes. And if you had stayed until now hearing me talking about this, then you really learned something new, I'm guessing. And hope you like this video. If you really like, give me a thumbs up and subscribe to How to Learn channel. I'll anyway come back to you with this ORA 600 error code, why this error code popped up and why was my MRP process interrupted. All that as an addendum to this video, or I will add a separate video for this because it's anyway very lengthy video. So thank you guys. Thanks for staying with me, and we'll meet you in the next video. Thank you. Bye. All right. As an addendum, guys, like I said in my last video, in the previous video where we ran a long duration, right? The MRP process died with ORA 600. This I just tried restarting the standby database and I put the MRP back again. It worked just fine. If I show you this, you'll see it. Now you see MRP is alive. I restarted the DB. Earlier it was failing. Now it's all okay. And no ORA 600 error as well. You can see here. The MRP came alive here. Yes, but it didn't fail after that. Now I'm gonna try load some data to really show you that this is not wrong. I mean, what you see is really correct. So I'm going to increase the number to 10,000. So if I just show you ID max ID from this table is 999. I'm going to, it's the same result here. Alright, if I show you this is at this point in time, this is the number of records available here. If you go query here, it will be the same number of records. Same now, saying max ID will be this. ID from is 999 only. Alright. You can see here it's at 1237. It's the same number matching this one source. I'm going to load some 1000 more records. And let's see. It's created. I'm committing. And now my max ID should have upsized to much more than this. 10,099, 10,999. All right, yeah, just run it with the end users. Sorry, schema prefixed. You can see the recovery is running, guys. So this is all I wanted to show you. Thank you, guys. Thank you for staying with me. I hope you found this video really useful. If you really like, give a like and share with your friends and colleagues. And subscribe to How to Learn channel. Thank you. Bye. Welcome back. Thank you. Bye.